Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 23rd. First, we take a look at significant wave heights for the North Pacific Ocean, a rather placid pattern in effect at the moment. Only low pressure or system of interest is low pressure here, just west of the dateline, not doing a whole lot at the moment, and some seas from a previous fetch working its way into Vancouver Island area, only in the 17-foot range, and otherwise not a whole lot going on. Let's go see what's coming for the future. First off, let's take a look at jet stream level winds. These are winds up above 30,000 feet. They help support the formation of storms and also help direct the track of storms when they do form. What we're looking for is strong winds, and we have them right here, 170 knots, falling into a trough. This is an area supportive of low pressure in the upper levels of the atmosphere, supports counterclockwise circulation that normally manifests itself as low pressure down at the ocean surface. Anyway, got a good trough here, northwest of Hawaii. Looks like it could support gale formation. And then the jet stream ridges, that is, pushes to the north, helps support low pressure down at the ocean surface. And that's exactly what's happening off the California coast right now. And also trades pushing into Hawaii. Also, we have a weaker jet stream pattern pushing off Japan, a little bit troubling. What we want to see is a more consolidated, strong fetch, or not fetch, but wind flow the whole way across the North Pacific. Looks pretty good from about here off to the east, but off to the west looks weaker. Anyway, let's put this in motion, see what happens. As we roll forward in time into Monday, the trough starts getting pinched off. That starts slowly diminishing its ability to support low pressure at the surface. Ridge continues pushing into the California coast, and weakness continues off of Japan. Roll this out into Tuesday and then Wednesday, and the whole jet starts to split there, and just really very not much cohesiveness at all. It's sort of fragmented and all over the place. Anyway, roll that out into Wednesday. You have this sort of cutoff trough thing going on here. So there is sort of a trough, but most of the energy is flowing up into Alaska and then down into the U.S. west, over like Canada and down into interior U.S. Another sort of split thing going on here off the Kuril Islands. Roll out even further, more of this sort of just, the split starts healing itself by Thursday, late Thursday. A little bit of a trough trying to form here, but not a whole lot of wind pushing into it. Roll that out even further, and you have just this big split here over Hawaii. That probably supports high pressure, probably high pressure there. But there is a trough by Saturday digging through the Gulf. That would support low pressure here. Roll that out even further. The trough gets better organized off the U.S. West Coast. This would probably support a low here off Vancouver Island or so. But everything else is just kind of a mess here out into, so we're a week out. And then it's over. And what this basically is a symptom of not enough wind energy in the jet stream, which is symptomatic of the inactive phase of the MJO, and that is what's going on, at the macro level picture, and we'll get into that in a minute. So let's take a look down at the surface, see what impact the jet stream level pattern has on actual gale formation at the ocean surface. And of course, it is gales and wind on the ocean surface that creates seas, and seas, as they radiate away from the fetch that creates them, create surf. Swell and surf. So, as expected, high pressure off the U.S. West Coast with the ridge and the jet stream there. North winds basically from San Francisco southward, and then trades into the Hawaiian Islands. Another high pressure center here near the dateline, and then we did notice that little low pressure and some seas trying to get going here west of the dateline. Not a whole lot of fetch though, 30 knot winds at best. We'll put this into motion. That little fetch here gets slightly more interesting, 30-35 knot winds. There's more faster winds here, or more velocity in the winds, but they're all aimed north, so that will really have no impact on Hawaii. It's that little fetch there aimed at Hawaii. Also, a new cutoff low forming, or forecast to form on Monday. It's only 25 knot winds aimed at Hawaii, and again, most of the fetches on the front side of this, really interaction of this low pressure and high pressure here creating a gradient and causing south winds. Sort of the same deal going on here with this high pressure and this low here. Anyway, roll that out. This low starts rolling off to the north. 40-knot winds over a very small area aimed at Hawaii. This looks better. 45-knot winds aimed at Hawaii. A little bit of fetch starting to push towards the U.S. West Coast. That's on Monday night. Better 40-knot winds at Hawaii into Tuesday, and then starts wrapping around. Also 45-knot winds here aimed at Hawaii. So small, but some areas of interest. And this is even better by Tuesday night into Wednesday. You have almost 45-knot winds aimed directly at the U.S. West Coast, with also more fetch aimed at Hawaii from this one. So that looks good for sideband swell for Hawaii and more direct energy for the U.S. West Coast. And then kind of a continued windy, unsettled pattern over the northern dateline region. Roll this out some more. Theoretically, this low continues to evolve. We're into Wednesday night, moving into Thanksgiving, and another low pressure pushing off of Japan, but not really a whole lot of fetch aimed at the islands and a good ways away. Here we go, more 30-knot winds. This is Thursday. And then that system sort of falls apart and starts meandering in the U.S. West Coast. This system here gets better organized, getting ready to approach the dateline. 40-knot winds and starting to take aim better at Hawaii. This is 144 hours out, or Saturday morning. And then we're into, let's say Sunday morning. There's 40-knot winds aimed at Hawaii. Also this new fetch here, and we saw the jet stream started dipping to the south through the Gulf of Alaska. 40-knot winds aimed at the U.S. West Coast, so it may be good for some more swell. Falling south also looks like kind of a stormy pattern by late in the Thanksgiving weekend for the U.S. West Coast. And again, more 35-knot winds for Hawaii, and that's it. Let's go take a look down at the surface, see what all this means in terms of sea production. First off, we're going to take a little bit look back in time. Little gale here, 28-foot seas on Wednesday. That was Wednesday last week. That is the swell that is currently hitting California right now. It arrived on Sunday. Got up to about, here we go, 34-foot seas on Thursday morning. With a little bit of lesser fetch in front of that. That's the swell from this area has already arrived and gone. This is what's hitting right now, with lots of local bump intermixed as well. And then here's another one behind it. This was as of Thursday, 20-foot seas, and keep your eyes on this one now. This is what'll be interesting. This will be for the early part of the Thanksgiving Day weekend for the U.S. West Coast, and is currently on the verge of hitting Hawaii now. 20, 22, 24, almost 25-foot seas in this area. Actually, that's about the peak of it right there. Relative to Hawaii, it was pretty north on about the 335-degree track. And relative to California, that's about the 296-degree track into Northern California. And for Southern California, about the 301-degree track. Anyway, that was Friday morning. The system continued east, started falling apart, 22-foot seas, and then pretty much died out. And then that gets us to current time right now. And here's the pattern we see. Low pressure developing here and swell radiating into Vancouver Island. So we roll this out into time. Sea production, not a whole lot going on with this low here. Here's the new cutoff low starting to form on Monday night. And then we get into Tuesday. Finally, a little bit with this system, but notice the way the swell vectors are pointing more towards Alaska relative to Hawaii. They're almost going 90 degrees to the direction they should be heading to move into Hawaii, so probably sideband energy at most. Really, relative to Hawaii, this one here, let's put this back. Yeah, that's about it right there. See, there's about 24-foot fetch going down about the 15 to 20 degree track into Oahu. And then also relative to Northern California, that's like the 84-degree track into Northern California. This one actually has some more interest for Southern California on about the 88 or 89-degree track, maybe 290 degrees into Southern California. And that's 28-foot seas. That's good for probably 15 or 16 second period swell. It just sort of continues to ferment there. 84 degrees for Northern California. We're into almost Wednesday morning now, and relative to Southern California again, about the 290 degree track roughly. and we'll roll that out some more. You can just see it sort of evolve, and then it falls apart eventually. So anyway, this system looks good for a little bit of northern, for Hawaii, and also a little bit for California, with energy probably doing pretty well into Southern California. And this is as of Friday. Still more to come. Another system developing in the West Pacific, and another one in the Gulf of Alaska. What's that, about 25-foot seas, very north relative to Northern California, 310 degrees, and nothing really pointed at Hawaii yet. But as we roll this out, there we go. Now here's for Hawaii, about the 303 degree track, and that's at 24-foot seas. So, like maybe a 14-second period swell for Hawaii if it develops as expected. This one's too north for Southern California for the most part. Again, about the 306 degree track into San Francisco. Roll that out. It does fall south and gets a little bit in the, it's still, 295 for Southern California. And this is as of Sunday night, a week out, if that's even believable, and 285 for Northern California. So again, it sort of looks like and we're out 180 hours. So pretty much a continuation of the same pattern. Limited sideband energy for Hawaii, a little bit more direct energy for California, but nothing strong in terms, just no solid storms with 50-knot winds, or even a large fetch of 45-knot winds. All just relatively small systems, not quite getting it together. Looking at the jet stream level charts, that's obviously the culprit. The jet stream is fragmented, doesn't have a lot of wind energy, and that's all due to what we believe is the current inactive phase of the MJO, and we'll get into that in just a second. Southern Oscillation Index numbers. We're looking at long-term trends now. The daily average, minus 6.87. 30-day average, minus 7.58. The 90-day average, minus 7.77. Notice hovering right around 0.8. Last week and even the week before, we were saying the same thing. It's been almost a month and a half now. The 90-day average has been holding at minus 8, which is a good place to be. That's generally suggestive of some sort of weak El Nino. We were on a good tear of negative numbers, and then starting about the middle of November, things started moving more positive. This is when I say positive, that's positive numbers. That's not necessarily a good thing. In fact, it is not a good thing. Again, that suggests that the Madden-Julian oscillation turned from being somewhat active to starting to fall apart a little bit and moving generally inactive. So here's the 30-day average over several years. 2012, we had a little run of negative. This is the 30-day average mapped out over time. A little bit of run of negative numbers. We thought we had El Nino going there. It fell apart. All through 2013, we had positive values. In January of this year, the bottom dropped out. We finally went negative. Massive Kelvin waves, westerly wind bursts, the whole bit. It looked like a giant El Nino was on the way, and then it quickly fell apart. But the good news is, starting in about June, the SOA started slowly, steadily working its way negative. It's been negative for, 1, 2, 3, 4, 5 months, going into 6 months. That's really quite good. It's imparting energy to the atmosphere. We believe that we're in some kind of an El Nino right now. Just about all the indicators suggest it, and we'll get into looking at that more in a minute. So the interesting part, what the thought is here, the atmosphere should be responding. We should be seeing storm production. It's just right at the moment we're not seeing a whole lot. Actually, the fall season started off quite good with a good run of multiple strong storms, but we're kind of in a doldrum here at the moment. Let's figure out why. So here we go, surface level wind anomalies, and this is really what it's all about. What we've been going through is a patch here of easterly anomalies. If you're in the active phase of the Madden-Julian oscillation, this is Australia here, in the West Pacific, you'd expect to see westerly wind bursts, or at least westerly anomalies. You'd see these arrows going the opposite direction where they are, and specifically in this zone from about 140 to 170. See, we have a little patch there of westerly anomalies, and just a couple of degrees either side of the equator. But what we've been going on for about a week now is easterly anomalies here. This is the first time the entire year that this has happened. it's been consistently neutral or slightly westerly, which suggests, you know, the active phase of the MJO or perhaps El Nino, and it pushes the westerly anomalies push a lot of water to the east. This is the first time this year that this has happened. Sort of suggests that the Madden-Julian oscillation, which has been basically gone for the entire year, or acting at least as if it's in some sort of a continuous state of being active phase, this is the first time it's sort of given up and retreated and allowed easterly anomalies to occur. Anyway, over towards the dateline, weak westerly anomalies. And we go over to the East Pacific. There's Hawaii right there. There's Mexico. We see some westerly anomalies here, but really they're too far to the east to support Kelvin wave development. Here's the cutoff line, 170 west here. Once you get westerly anomalies east of there, it doesn't do anything to support Kelvin wave development. So it doesn't mean a whole lot for us. And so that's kind of it. Let's go take a look a week out. A week out, we have a little bit better picture. I actually see, here we go, a couple little arrows of westerly anomalies, but again, another pocket of easterly anomalies here. This is the Kelvin wave generation area, 140 east to about 170 west, so basically draw a box right there. Basically, it will say it's a dead neutral pattern. Interesting part here is there are westerly anomalies trying to work their way into the Pacific, and that's exactly what we want to see. Also, again, in the East Pacific, pretty much a neutral pattern right here along the equator. That's all that matters, a couple degrees either side. So no big change for the next week, other than perhaps weakening of the easterly anomalies. This is the same view, but over time. So here's October into November, and then if you go here, the area we're interested in starts about here on the chart. That's actually about over here. And the Kelvin wave generation area is about along this line here. The Galapagos would be about here, and the Philippines over here. Anyway, we look back in time. These yellows and oranges are westerly anomalies. The blues are easterly anomalies. Okay, so there's a little patch there on November 3rd for a couple of days, but it wasn't much. But here you go, starting about the 11th of November, easterly anomalies developed, and they've been continuing into, well, here we are, and still even about maybe another 3 days of that's forecast, and then another little easterly pocket is scheduled on the dateline, if one is to believe that. All your westerly anomalies are over in the Indian Ocean, and that would suggest that the active phase of the MJO is in the Indian Ocean, and that's what we believe to be the case. Outgoing long-wave radiation analysis. Oranges and yellows suggest more reflectivity, sunlight reflectivity off the ocean's surface, meaning high pressure, meaning easterly anomalies, meaning the inactive phase of the MJO. Blue means less reflectivity off the ocean surface, more clouds, westerly anomalies, the active phase of the MJO. And so this sort of sums up where we're at right now. Inactive phase in the West Pacific, easterly anomalies. Active phase in the Indian Ocean, and westerly anomalies. Over time, 5 days out, our inactive phase starts fading. The active phase starts working towards the West Pacific, and per this, the statistical model, about, not even 2 weeks out, maybe 10 days from now, we should start seeing westerly anomalies moving into the West Pacific. That'd be a great thing. The inactive phase starts fading south of Hawaii, and when this happens, if it were to happen, then you would see more tropical air being transported up along Hawaii. The jet streams should start getting a lot more coherent, and storm development should pick up. So sometime in, roughly maybe the first week of December or so, per this, the statistic model. And interesting now, the dynamic model, again, shows the same sort of pattern. It was interesting, like a couple of days ago, there was no suggestion whatsoever that the active phase would make it into the West Pacific. Now it's starting to pick up on that. So in either case, it's looking now like about 10 days out, we'll start to see westerly anomalies, or at least a neutral pattern set up in the Kelvin wave generation area. The jet stream should start waking up, and storm production should increase, and therefore surf should start beyond the increase. Again, it's hard to believe a model 10 days out, but it's at least a positive something to look forward to. the 40-day upper level model. Greens suggest precipitation, yellows and orange areas not supportive of precipitation. So what this it's sort of a muddled view here, not nearly as coherent as what it was even a couple of days ago. So what this suggests is whatever inactive phase there was, it's just kind of fading out. The active phase is supposed to get going by 3rd of December. Here we go, down to the 13th, and then it kind of dies, and then we just sort of go back into some sort of a neutral pattern, which would be okay as long as there's no easterly anomalies. As long as there's either neutral anomalies or westerly anomalies, then the jet stream will sort of wake up and we should be good to go. And one more view of surface wind anomalies. I know we've kind of beat this to death. This is actual wind speeds, but it's the difference or the difference from normal for this time of year, and that's what we're really interested in. Kelvin wave generation area is again right in this box about here. There's your easterly anomalies, a little bit of western anomalies. This is from the TAO buoy array. Buoys strung along the equator here. Ground truth. No modeled data here. This is absolute truth. And so all this is reflecting is basically what the models were showing before. So just more confirmation that we have easterly anomalies. Next, we'll take a look at ocean surface temperature anomalies. That is deviations from normal for this time of year, for this part of the ocean. Notice, and here is actually something very good to notice. Warmer than normal waters building over the entire Nino 3.4 region, the area that NOAA tracks to determine whether El Nino is in place. And they start right here, a couple degrees either side of the equator, and look over to about right here. So 170 west, 120 west, and you look there and you see definitely warmer than normal waters, roughly 1 degree above normal across the entire region with pockets of 1.5 degrees. And then notice it's even warmer here in the Nino 1.2 region off of Ecuador and the Galapagos Islands. But really, in terms of having an effect on the atmosphere, it's this area right here. When this warms, this helps impart energy to the jet stream, helps fuel the storm track across the North Pacific in the winter, and then helps support more storm development. Also notice warmer than normal temperatures off the entire U.S. West Coast. In fact, the entire Pacific Basin is full of warmer than normal water. And you look at the entire planet, for that matter, along the tropics, and it's all warmer than normal. So there's something actually going on here. We actually talked to NOAA, and they suggest that, well, clearly, ocean temperatures are warmer than normal across the entire planet, and this has been getting warmer continuously for the past 30, 40 years now. They have a thing called a climatology. That's what they use to build these images, and they have they'll do like a 30 or 40 year base period to determine what's colder than or warmer than normal. And what they've said is they're going to change their climatology. The climatology they were using was, I don't exactly know the numbers, but roughly 1920 to 1980 or something like that. Okay, and what they've found now is because the oceans are all getting warmer, they got to go update the climatology, make it more recent. And what you'll see probably is a lot of this warmer temperature, especially on out on the peripheries, disappear. And this is at least in terms of for monitoring El Nino. And then you'll see this sort of pop out a little bit more. Not that it's particularly warm or anything, but a lot of the noise around the edges will probably disappear. Anyway, let's go put this into motion and see what's been going on. So we're back in September, late September, lightly warmer temperatures across the equator, but nothing particularly, that really gets your eye. Certainly no warmer here than anywhere else, except this little pocket here near Ecuador. But again, it's this area boxed right in here that were of most interest. So we'll put this into motion. Watch how this goes. You see, little bit at a time, this area that was cooler is disappearing, and here we go into late in October. Notice these little warm patches started developing. There was 2 Kelvin waves in flight. The first started hitting, that's warm water erupting off of the Galapagos, and then started get caught as it erupts to the surface. it starts getting caught by the trades and blowing into the Nino 3.4 region. And as we run this by in time, look at that. You see it all starting to fill in. This is current now. So this is the warmest the Nino 3.4 region has been all year. Looking pretty good, looking like a weak El Nino. Nothing particularly strong, but it's got to go like this for at least 5 months before they declare El Nino. And typically El Nino peaks out in right around the Christmas time area. So whether we actually make an official El Nino kind of seems like a long shot, but that doesn't mean it doesn't have the same impact on the ocean surface, or I'm sorry, on the atmosphere. And then, of course, the zoomed-in view, again, anomalies right across the equator. Again, 1 degree anomalies across the entire equator, across the entire Pacific Ocean, with patches of 1.5 to 2 degree anomalies here, here, and here. So again, all this sort of comparing, contrasting, all saying basically the same picture, or giving us the same conclusion. And finally, subsurface temperature anomalies. Here's actual water temperatures on the equator, 2 degrees north to 2 degrees south across the entire equator from 140 east, so that's the beginning of the Kelvin wave generation area, over to the Galapagos Island. It is the anomalies that are of most interest. Notice a pocket of 2 degree anomalies working their way up towards the Galapagos Islands with a core of 4 degrees. This is a Kelvin wave, the second of which, that in quick succession, that it's about ready, we'd say still probably about a month to a month and a half off before it actually starts erupting at the surface, and probably 2 months before it actually starts working its way into the Nino 3.4 region. So that's November, December. So sometime in January, peak warming, late January, you get peak warming at the surface. And this is much warmer than the previous one, so we would expect to see temperatures go up even more on the surface, which again would help support the jet stream more, which would of course support storm development. Here's another version of that as of November 14th. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This version says about 4.5 degree anomalies in its core. It's actually cooled down a little bit since the 14th, but not much. And one last view here. This is upper ocean heat anomalies. Again, over time. Here's the scale. 140 east here. That's the far west Pacific. 80 west, the Galapagos Islands. Over time, 1 Kelvin wave from October of last year. The big Kelvin wave, January, February, March, working its way into the Galapagos. And notice cool upwelling in between, the upwelling phase of the Kelvin wave cycle. And then here's the current, this is a Kelvin wave that's currently erupting, causing the warm temperatures on the equator that we're seeing as of right now. And yet another Kelvin wave, the one that we saw buried down under the Pacific Ocean, that's the one that's in flight now, starting to work its way towards about 110 west, not quite to the Galapagos yet. And that's the one that we expect to be erupting at the surface over into January, maybe February or so. The other thought is the easterly anomalies, this little change. Notice you get these cool anomalies in between the Kelvin waves. The thought is maybe these easterly anomalies are the upwelling phase of a Kelvin wave, the start of the upwelling phase that's to come after the end of this Kelvin wave, which maybe, maybe not. It's sort of a guess more than anything, but something to consider. Anyway, so that's sort of the subsurface look. And finally, let's go take a look at the model, see what the long-term projection. The CFS version 2 forecast for the Nino 3.4 region, these are monthly anomalies. Currently, we're at 1 degree anomalies. The model says temperatures to hover there, maybe go down to 0.09 through and holding into April and May, and then temperatures shoot up maybe to 2 degrees or more when we get into July. And that's not even into the heart of the Kelvin or the El Nino cycle. If you're out into December, January, you could see temperatures above that, if one is to believe a model that goes that far out. The point being, though, that there's Kelvin waves in flight right now. We're in what we call a Modoki El Nino. It's sort of an El Nino, but not really an El Nino. We're barely at the threshold, certainly not having the duration. If this was a real El Nino, it would have started doing its thing way back in July of this year, and it clearly did not. It didn't even really get into the zone of being El Nino-like until after October. 5 months, you'd be into February before they'd even declare it an El Nino, and that's probably too late. So this year is probably not really an El Nino, but 2 years of activity would be great. You get piles of momentum in the atmosphere. We not only get all the goodness from the warm water for this year, but then next year could be a much stronger event and much larger surf event. So anyway, that's what the models look like. For the immediate future, surf for California, surf for Hawaii. Nothing large, more like a continuation of what we've been having, but good tune-up, just waiting for really the Madden Julian oscillation to start going active, which we think will happen probably, let's say, the first week in December. That should get us December, pretty much the whole month of December with a much stronger surf pattern. And then, of course, the El Nino situation looking good for the rest of the year. The question is, will it be a multi-year event? Will next year be stronger? We hope so. The good news is even a weak El Nino or this Modoki El Nino this winter could help support a better summer too. It's the southern hemisphere tends to pick up on some of what happens in the northern hemisphere the season after. So that's something to look forward to. And then a year out beyond that, maybe a stronger El Nino, but not all the models support what the CFS V2 model says. So hard to say, but either way, things are definitely looking much better than they have been for 4 years. So we'll go with it. So for now, enjoy, go get some waves. We'll do this again next week. Same time, same channel. See you then. Thanks.